Well, hello and welcome back to Null0 Labs. In last week's episode, you can remember that we worked on an active, passive, highly available Palo Alto firewall setup. In this week's example, we're going to walk through setting up active. And now with this method, we'll be able to balance traffic across two firewalls at the same time. Whereas when we used active passive, one firewall was doing the work all the time unless there was a failover, which caused the second firewall to then start processing traffic. So we're going to jump into our lab. And from what we can see here, pretty much the same as what we had before. We've still got our ISP's gateways up the top. They have set up a VRRP for us, and they have given us a /24 allocation. We have a test machine connected out on the internet that we will use later to demonstrate the inbound NAT, because we will be using ARP sharing for IP ARP sharing for the IP address for the destination NAT inbound to one of our devices. Our source NATs will use floating addresses, because that will bring on to the next bit, because each firewall will have its own IP address. Whereas before, if we take the inside example, our two desktops down here had a single gateway address, 2120.254, and whichever one was active, the gateway floated backwards and forwards. With an active configuration, we're going to use two floating IP addresses per node, so that whenever a firewall does fail, the clients that are configured to point to firewall 1, the IP address will float over to firewall 2, allowing those clients to continue in the event of a fail. Likewise, firewall 2 will have its clients pointing at a floating address that will migrate over to firewall 1 in the event that firewall 2 fails. This allows you to be processing traffic across both devices at the same time, and in the event of a failure, one of those firewalls can take over in the failover scenario. So what you've got to understand is that even though you're using two firewalls and you're spreading the load, your firewalls need to be able to handle the combined load of both firewalls combined if there was a failover scenario. So and then also we've also looked here at our HA links. We've added an additional HA link. So where before we had HA1 and HA2, we've now added HA3. And HA3 is for our sessions. So for session setup in asynchronous scenarios, because obviously as we're going to have traffic coming in, could come into the left firewall or it could come into the right firewall. Especially on a destination NAT. So we're going to have sessions that both firewalls need to be aware of, and the firewalls may hand sessions over to firewall 2 for processing of layer 7, but firewall 1 may be handling the NAT session setup. So inbound NAT, the session may come into firewall 1, it will respond to the upstream host, and it would then send the traffic over to firewall 2 across HA3 for processing back and then down towards the client. Obviously, the MTU size needs to be enabled for jumbo frames on these interfaces, as the packet size is going to be larger than 1500. Right, so let's get started with some basic housekeeping on this diagram here. I'm going to lay out the IP addresses that we're going to assign to the interfaces, along with an IP address for our destination NAT, which we'll be using for inbound to one of our test nodes. So whereas before we had one gateway, and it floated for two, we're going to create two, but we're going to start with numbering our interfaces. So to make this easy, the left one, its physical interface is going to have an IP address of 1020.253. I'm going to duplicate that. Firewall 2 is going to have a physical interface on there of 1020.254. and we're going to assign a floating address. So I'm just going to call this float so we can see, and this will be 252. And then this firewall, its floating address will be 251. So you can see from here what we're going to do. This machine down here, its gateway is going to be 20.251. This machine, its gateway is going to be 20.252. And then in the event that this machine, this firewall ever fails, this floating address will float over to here, and firewall 1 will take control of this IP address, and this host will go out in this direction and back in again. Likewise, on our public side, whereas before we only had to use one of our public IP addresses, we used the next available one, which was 2.4, and it floated between the active or the passive device. In our active scenario, again, we're going to have physical IP addresses on our interfaces and a floating IP address for each firewall. And now we use those for our outbound NATs, our source NATs, and we also use those for our VPN endpoints and stuff like that. So we could have a node on the internet that will be VPNing to this floating IP, and then in the event that this firewall fails, it will move over here and the tunnel will then continue. So again, let's label those. So I'm going to duplicate one of these just so that we can use it for our physical interface address. So the physical interface address out here, but as we're already using .1 as the VRIP, .2 for the ISP gateway, and .3. So we're going to go, this one will be 2.4. And this one will be 5. And then we need a floating address for each outside interface again as well. So you've got to remember we're going to be using a few more addresses than we were using last time. Sorry, I've numbered that wrong. It was public IP was 192.0.2. This one will be 1, 2, 3. We're going to 4, 5. This will be 6. 192.0.2.6. Its actual physical address is 192.0.2.4. And this one we said was 192.0.2.5. And then its floating address is going to be 2.7. So when this machine NATs outbound, it's going to be NATing out and using this public IP. When this device goes via this firewall and it NATs out, it's going to use this one. In the event of a failover, the IP will float over, and again, the IP will float over, and the NAT policy will continue to function. You'll see as we do the setup. For our inbound NAT, our destination NAT that we're going to set up to this device here, I'm just going to put it off to the side for now, but our destination NAT IP that we're going to use for 21.20.8 will be 192.0.2. Let's use 100 out of our pool. So we're going to use this one as our inbound one, but I'll put it over here for now because we don't want to concern ourselves with it. So this is what we're going to configure. I've removed LACP from the scenario just so that we can concentrate just on the traffic flow, because this is complicated enough as it is and we don't need to add anything else to the mix. So let's start with firewall 1A, which is our left firewall. Now to start with, all I've done is under the setup, session, I've enabled jumbo frames. Once you enable this, you will have to reboot the firewall. So we've enabled jumbo frames, we've given our firewall a name, and we've configured date, time zone, etc. And we've done that for both of our firewalls. So the first thing we're going to do is we're going to jump into HA on the left firewall. So don't think of these now as active, in the terms of active and passive, where you add a primary and a secondary, or an active and a passive device, as both devices are active, and configuration changes that you make for things like policies and stuff like that will synchronize between the two. You can literally log into any firewall to make these changes as you're going through. So let's start by enabling HA. So I'm going to enable HA. I'm going to give this a group number of 10. Now it's going to be active. Now this is the left device, firewall 1A, so it's going to be device 0. We're going to enable config sync, and I'm going to set up a 192.168.100.2 as our peer. And then I'm going to jump into our networking settings. And we are going to do E1/5 to 7 as our HA interfaces. So let's enable these for HA. Obviously, if you're using a physical firewall, you'll have physical HA interfaces that you could use. Sometimes you also recommended to use the management interface if you don't have dedicated HA interfaces. And then for your HA2 and HA3, if you have a SFP HIC interface on your firewall, you can use that with a passive DAC cable is the recommended, so that you can use that for your HA2 and HA3 traffic. So, but on the virtual environment here, we're going to use in-band ports and enable them for HA. So we've enabled our 3 HA ports. Now I'm going to come back over here. We are not going to change anything under our election settings for this device. 100 is the default, so we'll leave it as it is. We're not going to turn on preemptive because there's no point, because we're pretty much active. There's not one that we really want to be falling back over as the main primary. There is the element of active primary and active secondary, and you'll see that when we set up our inbound NAT, as we can only have one of our firewalls handling the ARP response for that IP address. Otherwise, you will get network instability. So we'll leave these as the default. We'll jump over to our HA communications as we normally did. And we're going to set up port 1/5 as our HA1 port. And it's going to talk to 192.168. Our one is 100.1. 255.255.255.252. I think that's the subnet I used. 192.168.100.2 is the peer, and we are going to be 192.168.100.1. So that's correct. We're not going to enable encryption because they're back-to-back connected. That's all good. So we'll click on OK. HA2. We are going to enable session synchronization. We're going to use E1/6. The transport mode we're going to use is Ethernet, and we are going to do HA2 keep alive. And then finally, our packet forwarding interface, HA3, we're going to use E1/7. We are going to do some VR sync because we're going to have our, and you can only use this if you're using static routes. If you're using dynamic routing, leave this turned off. As we're only going to have one default static route, we want to synchronize our routing. So we're going to enable that. We're not doing anything with QoS, but we will turn it on just in case we want to use it. Make sure that all of your interfaces that you're using across the 2 active devices have the same speeds and duplexes. The recommended session owner selection is first packet, and it is recommended that we start the session setup with first packet. So we'll click on OK. So that is our HA. So before we jump into our floating addresses, we may as well go ahead and configure our interfaces. So under networking, E1/1, and this is firewall 1. It's going to have a physical address of 192.0.2.4. So virtual router will be default. Our security zone will be outside for simplicity. We will do a 192.0.2.4/24 as the physical interface address. We're not going to change anything there. I will add a management profile just so that we can ping that address for testing. We'll permit ping only. We'll hit on OK. So that is our physical outside interface. Now our physical inside interface, E1/2, has an address of 10.21.20.253. So we'll do that. Again, it's part of our default router. New security zone will be inside. Again, for simplicity, you could have multiple VLANs, you could have sub interfaces. IP address 10.21.20.253/24. Okay. And again, we're just going to allow ping on that interface so we can test that it's up. So that's our two interfaces configured. Our virtual router, we're going to do a default route to our ISP. Call this the default, or default even, if I could spell. And it is going to 192.0.2.1. It is going out of the E1/1 interface. Actually, I've got that wrong. It's 0.0.0.0/0 is the destination, sorry. The IP address that we were going to is 192.0.2.1. And we're going to click OK. And OK again. So that's our default route. So we've got our default route. We've got our interfaces. We've got our zones. Next, we will configure our floating address. So we'll come over to our device and we'll go to our active configuration. We'll add for our E1/1 interface. We're going to add the floating address, which was 192.0.2.6 for firewall. So 192.0.2.6 is the floating address. Next, we set the device priority. So as this is the floating address for device 0, it gets the lowest priority. So we'll just go with 0. And then firewall 2 or device 1 will get 255, which is the highest priority. So basically, higher the number, the lower it is that you are in control of that IP. So device 0 has control of this IP address. And then in the state of a failover, we want it to move. We're going to click on OK. Also under E1, there would be the floating address for the second one. So we will add that. That is 192.0.2.7. We're not going to tick that it's bound. And then for device 0, we don't own it. Device 1 does. Okay. Then for our inside interface, E1/2, for firewall 1, the floating address is 10.21.20.251. So 10.21.20.251. Floating, and device 0 has control of it. Device 1 only in the event of a failover. And again, 10.21.20.252, device 0 does not control it, device 1 does. So only in the event of a failover should this IP address switch from device 0 to device 1. Likewise, this one should switch from device 0 to device 1 in the event of a link down fail. So that's our configuration there. So what have we done? We've configured our zones, we've configured our interfaces, we've configured our HA interfaces, we have configured our HA active device 0 firewall 1. We've configured our HA communications, we've configured our floating addresses, and we will configure our path monitoring for our device. So if we cannot reach the VRRP IP, which was 192.0.2.1, if the device cannot reach the default router, we want you to fail over, which will make the floating addresses move to firewall 2. Likewise, again, in the event, and we'll call this WAN, in the event that WAN 1 fails, we want you to move over downstream 1/2. In the event that that physically fails, we want you to move over. So now let's commit that and we'll jump over. Oh, nope, stop myself. Let's go and configure our policies quickly. So we're going to do our NAT policy. I'm going to call this SNAT device 0. And this is going to be coming from inside to outside with a source address of 10.21.20.0/24. And we're going to translate that to an interface address of E1, which is our outside, but we're going to do it to the floating address, which will be for our device 02/6. And we're going to bind that to device 0. Now these policies will get synchronized between both devices. So we're going to add a second one. So this will be SNAT-D1. And the original packet will be coming from our inside zone to our outside zone with a source address of 10.21.20.0/24. And we are going to translate it to our outside interface address and its floating IP of .7. And we're going to bind that to device 1. So anything going out onto the internet from device 1 will use this NAT profile. Anything going out of device 0 will use this NAT profile. Now let's add our security group. We'll call this internet. And again, this is going to be coming from our inside zone with a source address of 10.21.20.0/24. And it's going to be going outside to any address. And we will just say any application, any service for now. And we will allow the action and we will log it. So that should be our policy for internet access. Our NAT's configured. We have configured our interface, physical interface addresses, our HA interfaces. We've done our HA link and path monitoring. We've configured our floating addresses and their priorities. We've configured our HA communication, and we've configured our HA pair setup information. So now let's just finally go back to the dashboard. Let's add our HA widget so that we can see what's going on. Now let's hit commit and we'll be back to configure the second firewall with its information, and we will then synchronize both of them together. So let's let this commit. Right, firewall 1A has successfully been configured. So let's jump over now to our diagram again, and let's take a look at what we're going to configure here. So again, pretty much a similar configuration. We're going to configure our physical interfaces. The floating IP addresses that we've configured on firewall 1A will synchronize over, so we don't have to worry about that part, but we're going to do our physical interface addresses. Our HA configuration must match. We're going to do our default root entry, and then we should be able to synchronize. So let's jump onto this one. So we are now on firewall 1B. Again, it's got its name, the time and date has been set, the device has jumbo frames turned on and has been rebooted. So first of all, we're going to jump into HA. We're going to enable it. I think I used group 10. It's going to be active, active. Again, see here, we make sure you set this device as device 1, because this is now the second device. So device 0 is for firewall 1A. Device B, firewall 1B, is device 1. So we're going to enable config sync, and our peer address is 192.168.100.1. That's our remote peer. We are just going to make this one a lower device priority, but again, a higher number. Just there's a difference. Hopefully we should then skew firewall 1A to come up on boot as our main active primary, and firewall 1B our active secondary, just for, maybe if you've labeled them, at least you'll know which one's which when they come up by default. HA management communications, so HA1. Oh, no, let's go back to our network first. Let's specify our HA ports, which were HA 15, 16, and 17. So 15, and we are 192.168.100.2, 255, 255, 255, 252. No gateway because they're back to back. No encryption as they are back to back. HA2. We'll use the next one, 1/6. We will use Ethernet for our transport, and we will do keep alives. Our packet forwarding interface, HA3, will be on E1/7. We will do, let's just double check that we did turn those on, because these do have to match. Yes, we did. So we will do the same here. We will use first packet and first packet as per Palo Alto's documentation. So that's there. We will now do our network interfaces. So we will do our inside, our outside physical was a layer 3. It was part of the default, and this was our outside security zone. It goes without saying, you may want to make sure that you name and label things identically, just so that you stay in sync with each other. So 192.0.2.5 was the physical. We will create our management profile of ping only for our testing purposes. We'll allow ping. That gives us that. We will do the same for our inside interface, which was a layer 3. virtual router of default, new security zone of inside, and its IP address was 10.21.20.254. And again, we will allow ping on there for our testing. So that's all correct. That's correct. Our zones are correct. Let's do our link and path monitoring. So we'll do WAN. We'll monitor that. We will monitor our downstream. Okay, oh, I better do our default route, otherwise we won't have a static route. Add default 0.0.0.0/0 E1/1. Our next top IP address is 192.0.2.1, which is the VRP gateway. We will add that. So that's our default route, our zones, our interfaces. We shouldn't have to worry about policies, and we shouldn't have to worry about the NAT, as that will get synchronized. So we will just add our path monitoring, and we will go for a save our config, and we'll do a sync. So this was our default router, and we are destination to VRP IP, and it was 192.0.2.1. So we have our link and path monitoring. This will get synchronized. We have our control link set up, and we have our election settings and our pair group. So now let's commit this. Oh, let's go back to our dashboard first. My availability. Right, let's commit this, and we will check and synchronize and make sure all of our policies, NAT, and floating addresses are in place. Welcome back. Right, we can see our firewall 1B has committed successfully. We can see on our HA widget that everything is matching. The mode is active. We are tentatively waiting to become obviously the active secondary, as our peer firewall 1A is currently the active primary. So we'll be in a hold down timer for about 60 seconds. So we will come over to our secondary one. Our interfaces are showing us up, HA is up, zones, policies, nothing synchronized yet. Okay. So we have from our primary firewall, we are in active. We are the active primary node. The peer is the active secondary node. All of our software versions, HA links are up and matching. Now we're going to synchronize the config from the active primary to the active secondary. This should synchronize our floating IP addresses and the policies that we created for our security policy and our NAT policies. So let's let that sync over, and then we should start to see, there we go, we should start to see these things coming in. So we've got our source NATs, etc. coming online. Our internet policy is synchronized over. We go to our device, our active, we can see that yes, we've got our floating addresses synchronized, so that we can see that we are in control of 2.7 Firewall 1A is in control of 2.6. There we go, fully synchronized on both nodes. Right, okay, so let's look at what we've got set up. We have got both of our firewalls now configured in a active configuration. They are both configured with their floating IPs, their physical IPs. Now, if we jump onto one of our desktops, it was left in a state that it was pointing at the physical IP address of it was left pointing at the physical IP address of 10.21.20.254, which means it would go here and it wouldn't fail over. So we're going to point it at the new floating IP address for this device, and we'll point this one at this floating IP address, and then we can then test the flows out, and then we can then shut down firewall 1, and we'll see that the device on firewall desktop 7, its floating IP address will move across the firewall to 1B, sorry, or firewall 2 on the diagram, and desktop 7 will continue to access the internet but via firewall 2. But when they're both online, desktop 7 will go out of the firewall on the left, desktop 8 will go out via the firewall on the right. So if we log into desktop 7, we may as well open desktop 8 as well, as it will have similar requirement to have its gateway changed. So this is desktop 7 on the left, desktop 8 on the right. So let's change our gateway settings. IP address, our gateway, you should be going out of 251. And we will turn that off, turn it back on just to make sure that it sticks. And you will be using 252. Now, if we open a terminal on both boxes, okay, we'll do an IP route. So the default route for the one on the left is to 251 IP route. IP route for the one on the right is to 252, which is these floating addresses. So this machine should go to firewall 1 out onto the internet, and we'll get natted to 192.0.2.6, and the traffic from this one will get natted to 192.0.2.7. So let's test that. So if we put a ping in place to Cloudflare, we can see we've got traffic flowing from the left PC. We've got traffic flowing from our right PC. So now if we look at our firewalls and we look at our monitor and our traffic, so firewall 1A, we can see from inside to outside. There we go. We can see the source 10.21.20.7 to the internet. There we go. So we can see it's going out to the internet, and it is being natted to 192.0.2.6, which is correct. Look at firewall 1B, and it's the same again. We go to monitor traffic. We can see we've got traffic coming from 10.21.20.8, which was the PC on the right. It again is accessing the internet, and it is being natted via the IP address of 192.0.2.7, which is correct. If we look at our policies, there we go. We can see we've got hit counts. Look at our NAT policies. We can see that both of them are increasing with traffic going from one to the other, from the other. So our first test will be that we have got traffic currently flowing from the gateway through the gateway on the left and through the gateway on the right from our two PCs. So if we was to switch firewall 1 off, desktop 7 should continue to access the internet as the IP address that we configured will move over to here. Now the best way to show this for who's got control of the IP address is we'll log into the command line of the firewall. And if we do a show high availability virtual address, we can see that for our outside interface of floating, we can see that 2.7 is active on the second one. Yes, and we can see that 2.252 is active on the second one. We can see that 251 and 6 is not active on this secondary firewall here. They are active on this firewall because this firewall is up. So if I was to stop firewall 1, and if we bring up all of our machines, there we go, we can see traffic has resumed. On the one on the left, we've lost around 10 packets, not bad. And there, if we refresh firewall 2, we can see that now firewall 2 is in control of the virtual IP addresses for which was firewall 1. They have now successfully moved over to firewall 2. So all of the devices that were pointing at this gateway, this address has now moved over here, and they are now using this path out to the internet. So what will happen is we will now turn on firewall 1 again, and we will see that this address will float back to this device and traffic will resume via this device after our countdown timers and hold downs have completed. If we go to the dashboard of firewall 1B, we will see that we have now become the active primary. Now you're going to take a note of that when we do the next part of this setup, which is NATing inbound. So what we'll do is we'll let firewall 1A come back online, and then we will resume by configuring our destination NAT from our guy on the internet wants to be able to access, let's say this one here. We'll do an inbound NAT from the internet. We'll do an inbound NAT like we normally would, and we'll allow a policy to allow this device to ping. And then what we would like to see is what happens if the firewalls fail over and how that affects the inbound traffic flow. So we'll be back after firewall 1A is rebooted. Right, we can see that firewall 1A has started to come back online. It is now in its tentative state, waiting. Once that happens, it will resume traffic flow. It will get the status of active secondary as it is now, as it comes back up. So let's log in to the firewall on the left, firewall 1A. And if we look at the CLI for firewall 2, we can see at the moment, there we go, we can see that firewall 1 has resumed control of its floating IP address. Firewall 2 is no longer responsible for it. So there we go, we can see that firewall 1A is back online, but it is now active secondary. Firewall 1B is the active primary, because it was the one that didn't fall over. And we can see that traffic flows should now have moved back to firewall 1. Yes, there we go. So we can see now that our machine 20.7 is now going via that way. If we look at here we can see 20.7 traffic is no longer going out of firewall 1B. It resumes back to firewall there. So the next type of traffic we're going to look at is our inbound NAT. If we want to NAT a IP address out of our pool to one of our servers on the LAN. So how are we going to do that? So there we go. We chose an IP address out of our pool, 192.0.2.100. But who's going to control it? We can't have both of them answering it. We could end up with some network instability. So we're going to use an IP ARP sharing technique here. So we're going to put this address here in the middle because one of these will control it. So if we look at the moment, if we jump onto we are the active primary. So what we're going to do is we're going to go into our policies. We're going to do a NAT. So we're going to do a DNAT test, we'll call this DNAT test. So the original packet is going to be going from outside to our outside interface with any source address to our address of 192.0.2.100. The same as how we would always do a destination NAT. Obviously, if you're doing a PAT, you're obviously going to select the port that you're going to NAT, but we're just going to, for simplicity, we'll NAT the entire IP address. So we're going to translate that IP address to our internal address, which was 10.21.20.8. Okay, and then we're going to bind it to our active primary. So we only want one of our active firewalls to handle the ARP and NAT translation of that IP address. If you have both of them answering, it could cause some undesirable effects. So we set the role as primary. So whoever is the active primary will be the device that will answer the ARP request for that IP address. Okay, so we've added that. So next we're going to add on our outside interface under device, high availability, we're going to add another IP address here. And this is going to be 192.0.2.100. And instead of it being floating, it's going to be an ARP sharing address. And it says in the documentation to select it as IP modulo. So we've added our public IP that we are using for our destination NAT into our outside interface. We've added our destination NAT and selected that whoever is the active primary will control that. We will now add a security policy like we normally would. So we'll call this the DNAT test. The source going to be from outside with any source address to our inside destination address of 192.168, 192.0.2.100. And we will just allow everything for simplicity. I'll just move that above. I like to have inbound ones above our outbound. So let's commit that and we'll come back and do some testing. Okay, so our synchronization has occurred. Our config is saved on our active primary and it is synced to our active secondary. So if we now look at our active secondary, we can see the NAT that we added is in place, but the device that's controlling the inbound NAT will be firewall 1B at the moment because it is the active primary. So if we jump onto our test node, we should now be able to ping that device on the inside of the firewall because we are NATing and we have allowed a security policy to allow it to reach that device. So if we open in terminal, okay, so if we ping 192.168, nope, 92.0, if we ping 192.0.2.100, There we go. So we can see we are now sending traffic from a device on the internet. It's reaching the firewall and it is being NATed to our device down here using our destination NAT and our policy. If we refresh, we can see that there are hits on that policy on both. And so if we look at the traffic, outside to inside, we can see that there is traffic coming in on that DNAT test rule. Let's look at firewall 1A, policies, security, monitor, traffic. Okay, we did get one hit on there, but we can see that the NAT rule was processed on 1B. Now, as it's probably going to load balance, if we send a second session from node 11, let's see if that takes firewall 1A. So if we monitor here, okay, firewall 1B. Yeah, as this is the active primary, we can see that it is in control of the inbound NATs, which is good. So at least we know where it's coming from. Now we will do another test where we will now fail over, and some traffic is being handled from the outside in on firewall 1A as well. So now, as this is the active primary, let's stop the active primary device and we will see what happens to our pings coming towards our destination NAT IP address. We should see that firewall 1 will start to answer the request. Let's see where the best way to look at this is. Let's have a look on the ISP switches. Show MAC address table. We need something that's going to show us the ARP table, really. This one will probably do it. Because when it changes over, the Palo Altos will send out a gratuitous ARP to update that the NAT IP address of 2.100 is now available via the MAC address of firewall 1A. So let's see if we can do a show IP ARP so we can see the before and after. Okay, so there we go. So it is going to 192.0.2.100, which is our destination NAT IP. It's going to hardware address of 4.1. So let's have a look at our firewall. That is firewall 2's virtual MAC address 4.1. Now on firewall 1, we have the exact same as this, but it will say active load sharing. So if we bring up firewall 1A and we issue the same command, we can see what the MAC address is of this device, and then we'll compare it to the ARP table. So log on here. We do a show high availability virtual address. We can see our MAC address is 3.0.1 for our outside interface on firewall 1. We can see that that address is active here, but we've configured the system so that whoever is the active primary should be the one that responds to the ARP request. So now let's drop firewall 2. So we drop firewall 2. We will see, so this is our node on the internet, node 11. There we go. It was a sequence number 209 to 220, so roughly about 10 packets were dropped. Traffic has now resumed. If we look at this firewall over here, firewall 1 has now changed from active secondary to active primary, which means it is now in control of the floating addresses from firewall 2. It is now also in control of the ARP load sharing address that we are using for our destination NAT. So we can see that traffic is flowing inbound. If we look at our NATs, if we look at our PCs on the LAN, we can see that we have traffic flowing outbound as well from both of our desktop 8 and desktop 7. So traffic flows, boom, instantaneously change over. So now if we bring firewall 2 back online, and if we quickly jump to our gateway on the internet, we should see, if we do a show IP ARP again, we will see that the ARP table was updated. There we go. You can see it. The MAC address changed from .3 from 5000.004.001 to 5000.003.001, which we know is the virtual MAC address of this firewall. So there you go. So as you can see, we have high availability again. We have the ability to have our inbound NATs and have the IP addresses float. We have the ability to have traffic balanced, or not balanced, we have traffic shared. I'd call it shared. We share traffic across 2 different firewalls. But obviously there is added complexity. There is extra IP address usage. So you have to weigh up whether the benefits of doing active with the extra complexity outweigh and the requirement to be able to support both loads from in the event of a failure, and the costs of that, of adding a higher capacity firewalls rather than, but likewise as well the added complexity of NAT, making sure that you're aware that you assign your source NATs to the required gateways. The destination NATs have to be managed by a single primary node, so that you don't end up with confusion. If we do a packet capture on one of these interfaces here, we should see the ARPs being sent out for this load sharing address. Let's do a packet capture. There we go. Let's stop that. There we go. So we see the Palo Alto firewall 1A sending out its gratuitous ARPs to say, hey, this IP address is this MAC address. This IP address, which is our destination NAT address, is under the control of this address. Obviously, once firewall 2 comes back online, we will see that as this is the active primary, it will send out a gratuitous ARP for its floating IP address and now this destination NAT address, because it is the active primary. We'll see only firewall 2 will only be sending out the message for its 2.7 floating address, because it's not it'll be the active secondary. That gives you an overview of active. Thankfully, I think it was a lot simpler to cover this time with the removal of having to do LACP, etc. Obviously, you can do that. You could have LACP connections for your inside. You can have your sub interfaces, but then you've got to remember that when you're doing your sub interfaces and you're doing your floating addresses, every single sub interface would have to have its physical addresses. There would have to be an entry for each sub interface's floating address. So you can see that it will get kind of very complicated very quickly. So again, you have to weigh up whether or not active or active passive suits your environment. Active has quicker failover, more complexity. Active passive, slightly longer failover, but less complexity. Thank you very much for liking and subscribing to the channel. If you haven't already done so, please do. It really helps me and Sniff in the background here know that people are watching the videos and enjoying the content. Hopefully, like I said, we can start to expand our operation into using some physical hardware and demonstrating that. I'd like to be able to do that for you guys. Also, if there's a notification bell that you haven't hit that so that you know when I've uploaded a new video, and if you do see it, smash that like button as well once you've watched it as well, because that will also help. Next week's video, I think we will move away from the Palo Alto side and we will take a look at another major brand of firewalls, which will be FortiGate, and we will configure a highly available active passive FortiGate configuration, and we will compare the setup of using that equipment over Palo Alto. We will use the same lab. We'll just drop in a couple of FortiGates instead of the Palo Alto devices. So look forward to that video, and I'll see you next week.